If you want to see someone who doesn't know what they're doing not fix a motherboard, that's what this crap is. This is an ASUS H97M-E. The ad didn't say much, just faulty motherboard $10. And since it's Gen 4, and I actually have a working one of these, I bought the thing. Let's check for shorts, and this is the auxiliary 12 volts. The capacitors are charging, but at least it's not zero. And the second group of 4 is 4000 ohm and climbing. Check 3 volts, and we get about 500 ohm. 12 volts, and we get about 3000 ohms. And the 5 volts is 1.8k, which is okay. We check the battery, and it's 2.7 volts. The battery's old, but it should be okay. We check the current draw on the battery, and we're getting 3 microamps. That's so low it shouldn't be draining the battery. Next is the visual inspection, and the socket looks alright. After what happened with that ASRock board with the broken pins shorted in the bottom of the slots, I now check the slots, and they were all fine. Then further inspection on the actual PCB, and I see this, and it looks like liquid spills. The question now is, did a liquid spill kill it, or did he just store it somewhere wet after it didn't work? I think the spill is dry enough that if I plug it in, it won't do any more damage. Basically, I want to try it dirty, because if I wash it and it works, I won't know whether the motherboard failed or something else like his power supply. Unfortunately, when I tried to plug it in, I noticed this. A mangled USB 3 with a pin that looks like it's shorting to the case. For the test, I just bent the pins out of the way so they weren't touching the case. And this thing is totally dead. Let's see if we're getting standby voltage to the power pin. And we're getting 3.3 volts. The standby power LED is on, so it's not that. Even though I knew it probably won't do anything, I washed the motherboard. I didn't like those powdery oxides between the pins. This is becoming the new Yes Tech City board washing channel. Lol. I also got rid of that faulty USB 3 socket. And it's still totally dead. We do the unplugged CPU 12 volts, but that's not doing anything either. And this is where I hit a snag, because there was no board view in Schematic X. I was trying to think how I can do this without knowing where anything goes, and I realised if you're a beginner and you don't know what's connected to what, all you can do is just random stabs in the dark and hopefully you hit something. The first random stab in the dark was to check if the internal rails are shorted. You basically check all the inductors. The VRMs were about 30 ohm, and this supply rail was about 150 ohm, so it's not them. The next random thing was fuses, or more correctly poly switches, and all of them were fine. Next is random MOSFET checking. Flat 8-pin MOSFETs generally have the 4 input pins all connected together, and the 3 output pins all connected together. And beside those is usually the gate, i.e. the pin that turns it off and on. N channels should beep on the 3 pins because they're usually connected to ground. But you don't want the 4 input pins beeping because there could be an internal short. It could also be the load that it's grounding that is short. You also don't want the gate shorted to either 3 or 4 pin side. If you get a MOSFET that doesn't beep on the 3 pin side, that's usually a P channel. And to see if they're shorted internally, you check from the power rail. And it should beep on the 4 pin side, but not the 3 pin side. And the usual control pin should not be connected to either side. Also check the 3 and 4 pins to ground in case the nets is shorted. I think checking the VRMs for a short might have been a waste of time, because the motherboard didn't start when the CPU 12 volts was disconnected. Basically the power supply won't start if it senses a short on the 12 volt line, but when it's not plugged in, it's not going to see that short. I checked all the other MOSFETs to see if they're shorted internally, and if the pins are shorted to ground, this is an N channel so it's going to beep on the 3 pin end. But they were all fine. I checked the linear regulators for shorts, but didn't find anything. This doesn't tell you if they're going to be putting out the right voltage, so they could still be faulty. My next random/desperate tact was to test every single passive for a short on both ends, but I thought it'd be better to look for another board view from somewhere else. I eventually found it by searching for the actual file name. Shorts are easier to find, and you can kind of do it with dumb persistence. But imagine trying to find a break in a net without a connection diagram. It would practically be impossible without experience. First thing I wanted to check is if I have all my standbys, so I went for 5V SB ATX and started checking locations around the motherboard. And we had 5.1 volts here and 5.1 volts here. Back to our rails. We don't have to worry about these 5V SB dual and ME because they're not on. Next is 3V SB ATX. Here we get 3.4 volts, 3.4 volts, 3.3 volts. That seems fine. Ignore HDA and ADV. And lastly is this 3V SB. We got 3.4 here, over here, 3.4 volts down here, and over here. It seems like all the standbys are fine. Even though we checked the battery, it was only 2 of the 4 things you should check. We checked if the battery was flat, and if something was drawing too much current. We go to the board view and click on the positive of the battery. That goes through this, and then to this pin. And we check other points on this net. We got 3.3 volts at the battery and 3.15 on the motherboard. Next we test the crystal frequency, and it's coming out at 0. Something's wrong with that. We check the other side and we get 32.75 kilohertz, which is correct. We get our good motherboard and we're seeing 32.75 kilohertz on this pin and 32.75 on the other pin. And that means there's something sus with our broken motherboard with this crystal, or the net on one side. Our dead pin goes through a 15 puff cap to ground, which goes through a 10 meg resistor to the PCH, and the other end goes back to the crystal. The question now is the crystal faulty or the parts connected to it faulty? The good board is showing 1 mega ohm, but the faulty one shows about 15 meg. If the parts were shorted, it would be showing a lower reading, but then again there could be too much resistance and it's not getting through. I've checked this resistor on both boards and they're both 10 meg, so it's either this cap or the crystal. But then again it could be the PCH. Maybe it has higher internal resistance and the signal can't get through. Well, that sucks. I did absolutely nothing and now the thing suddenly works and I don't know why. I took off the PCH heatsink so I can better probe the parts under it. And I was getting oscillations out of this pin of the crystal, but nothing out of this pin. So I started checking if the caps were shorted to ground or the resistor was a higher value than what it should be. But I found nothing, just that this pin had no oscillations coming out of it. So I thought about it overnight and came to the conclusion the digital multimeter was reading wrong. But then the next day a video turns up from Learn Electronics Repair and it gave me the idea to test the crystal in a different way. This sounds stupid now when I think about it, but instead of testing the pins to ground, test pin to pin. As you can imagine, that just gives you garbage. So I gave up and did a quick test from pin to ground and it was reading the same 32.75 kilohertz, and this is when I realised I'm inadvertently testing the dead pin from yesterday. I don't know how, but now the pin is oscillating. So I plugged it in, pressed the power, and now the thing works. Who knows what it was? Maybe it was me removing the chipset heatsink. Maybe the solder balls are faulty and removing the pressure on it from the heatsink might have freed it up. Maybe the digital multimeter set a voltage across the pins when I checked them and it unstuck it. I also had the RAM removed when I did the quick test, and maybe that reset it somehow. This is unlikely because the crystal had oscillations before I plugged the RAM in and turned it on. Unfortunately, it's all just wild guesses now because we don't really know what happened. I upgraded to the latest BIOS in case that has something to do with it, but now we just put it through heat cycles and see what happens. Sorry, but it looks like it's going to be a mystery. But now that I know what to look for on the crystal oscillations, it kind of makes me want to look at that Maximus 7 board again because it has screwy readings from its crystals.